Okay, final packet lesson of Unit 1 in Pre-Calculus B. So the title is Day 2, Modeling with Functions. Really what we're going to do is just set up, these are basically story problems, really. So it says one positive number is 2 times another positive number. I know there's a tendency to want to involve like x and then maybe 2y or something like that, but we're going to stick with attempting to use one variable. And if we don't get that out of the way, I think I'll cause you more harm in the long run if I don't say this like right away. So if I say, hey, I want one positive number, we're going to call that x, is 2 times another positive number. And so we're gonna let that be 2x. And their sum is 480. It says find the two numbers. Well, if we got x plus 2x equals 480, we just add those together. And you know, I think this language should say one positive number is, and then it says 2 times itself. And I think there's a little bad communication here. So I apologize on behalf of math. But if we divide by 3, we divide by 3, we get 160. And then if we doubled that, we'd get 320. So I think this is a little bit confusing, possibly. But if you notice, look at it. One positive is twice itself. So this one is twice that one. And their sum is 480. So that's the way I would go about understanding that one, okay? So our two answers are 160 and 320. This one's a little more straightforward. Jen received a 2.5 salary increase. So here's her original salary, but then she received an increase of that. So that's 0.025. So we're going to go 0.025 times her original salary. We're adding it because it's an increase. Her salary after the raise was $24,400. Something tells me I'm going to have to pause this and go get my calculator. So we get 1.025x equals 24,400. Yep, going to have to pause. So I took advantage of that, and I already punched out these numbers, because if you divide by 1.025, divide by 1.025, you get x is 23,804 and some change, 87 cents or 88 cents. So what was her salary before the raise? Well, it was right here, because x is her original salary. Okay? So with that in mind, let's check this out. A traveler average, look at this, 48 miles an hour. There's a formula called distance equals rate times time. Think about it. If I go 50 miles an hour for 2 hours, I went 100 miles. The formula is not hard. But this says 48 miles an hour, that's my rate, per hour on a trip that took 4.5 hours. Well, just like that, not a big deal. So 48 times 4.5, 216 miles. There you go. Sometimes you get these easy ones. Gotta love it when that happens. But same formula, a little bit more complex problem. So the family traveled 450 miles. I can kind of see what's happening here. So I'm going to write start and then finish and just give you a visual of what's going on. So that whole distance is 450 miles from here to here. But it says they spent 2 more hours on the interstate highway traveling 60 miles an hour than they did on a local highway going 50. So we got to break this up into 2 parts. Now, I didn't intentionally make this look like halves because it wouldn't have to be half the time. I'm just breaking it up into 2 parts. But if I say, okay, I want the interstate highway to be here, and then my local highway would be here, then I have 2 scenarios. My rate and my time, my rate and my time are going to have to be added together. And then when I add these together, they're going to have to add up to 450. So now I have to piecemeal this together. So starts by saying they spent 2 more hours on the interstate highway than they did on the local highway. So I'm going to start with the local highway's time being X or T. Let's just go with T for time. The interstate highway, they spent 2 more hours on that. And notice they traveled 60 miles an hour on this portion. And then on the local highway, they went 50. So that goes here. So if I distribute, I'm going to get 60t plus 120 plus this, which is just 50t, equals the whole distance, 450. Now I just got to crunch some numbers. So this plus this is 110t. Subtract 120, subtract 120. I get 330. Look how nice that is. Sometimes math is too nice. Which is 3. Now wait a minute. What's the question asked for? I just found that t is 3. It says how many hours did they spend on each highway? Well, as you can see, t equals 3. So the pink trip, they spent 3 hours. So that'd be 3 hours. And then pretty obvious, if I put 3 in right there, 3 plus 2, they spent 5 hours on the interstate. Okay? All right, last 2. Hopefully I can get this done before the time runs up on me this time. This one's pretty simple. It says, from 1996 to 1997, the U.S. shipments of personal computers grew. So you can see 1996 is this one, 1997 is this one. So it says, what percentage increase in U.S. personal computer shipments? So what I'm going to do is I'm just going to keep it simple. I'm going to take and figure out how much they grew, 26,650,000. Just subtract. Let's go old school. Not going to use that calculator. I want to, but I'm not going to do it. 3, and that'd be 4. All right. So 4,339,000 computers. Now, how do we figure out percent? We take how much it grew. We put it over the original. 26,650,000. We're going to figure out what this decimal is, and then we'll turn the decimal into a percent. All right, well, I'm going to take these zeros off. Why? Just because you can. And I'm going to go 4,339 divided by 26,650. And that's 0.162. It goes on forever, but I just rounded it to here. How do we turn a decimal into percent? You move the decimal 2 places. 16.2%. Pretty good growth. All right. This last one, tricky. Kind of tricky. The chemistry lab at the University of Hardwoods keeps 2 acids on hand. One is 20%. Let's try to keep this color-coded. And the other is 35% acid. Okay, so what we're going to do is we're going to let this 20% equal X. We're going to let the 35% acid equal, now watch this, I'm going to read ahead. How much 20% acid solution, the pink, and how much 35% acid solution, the yellow, should be used to prepare, here's a very key sentence, 25 liters. So if this is X liters, then this would be 25 minus X liters, okay? Now, this one's still a little tricky. It says to prepare 25 liters of a 26% acid solution. That's a lot of numbers getting thrown into this crazy story problem. But here's the deal. So they've got 25 liters, all right? Think of it this way. But they only want the final solution to be 26% acid. So remember, this is liters. That's a mixture of like water and acid. But what's 26% of 25? Well, I got to multiply that by 0.26. And see, I'm finding out the pure acid. So times 0.26, that's 6.5 liters. So it's 6.5 liters. This is pure acid only. Okay, because I want 26% of the 25 liters of acid solution. So what I need to do is I need to know that this 20% of this is acid. So I'm going to go 20%, 0.20 times X plus 35%. See, and squeeze this in. 25 minus X equals 6.5. Got to crunch it out. 0.20X plus, got to figure this out. I do not have that memorized. 25, 8.75, pretty convenient. Minus, see, I'm distributing, 0.35X equals 6.5. I'm going to add my like terms right here. So I get negative 0.15x. I'm going to subtract 8.75, subtract 8.75. I can kind of look at that and say, aha, that's going to be negative 2.25. Now I'm going to divide by negative 0.15, divide by negative 0.15. And 2.25 divided by 0.15, 15. So X equals 15. Now what does that mean? It's saying, excuse me, it says how much 20% acid, that's 15, and how much 35% acid should be used to prepare 25 liters at 16%. So there it is. So I got 15 20 at 20%. If I plug that back in right here, I'd get 10 liters at 35%. That is a tricky problem.